Hello, everyone. Welcome. I see we've got people joining Prompt Like a Pro. I'm going to just go through some housekeeping items before I turn the show over to my friends Nick and Reggie, who are there standing by. Hey, guys. My name is Beth. I'm head of media here at Blitzy, and I just want to welcome you and thank you all for being here. As people join, I'm just going to go over what to expect. So today's live session with Nick and Reggie, they're going to introduce themselves and they're going to get started. I can tell you that Nick and Reggie work directly with enterprise engineering teams from some of the biggest companies in the world. And we're talking organizations with 100 million plus lines of code. And they're tackling modernization, technical debt, and finding all types of gains with AI. Now, these guys are the right people to have this conversation with you. And here's what you can expect. We know prompt engineering is one of the most in-demand skills in enterprise AI adoption. We know that teams are running into some real challenges. So you're going to walk away with a framework on prompting techniques that you can apply across tools and models with a durable strategy on structure and iteration. So we'll get that out to you after the program. So we will have questions and answers throughout. You can drop them in the chat. I will be moderating and popping in, and Nick and Reggie will forgive me when I interrupt with a burning question. So if we don't get to all the questions today in line with the conversation, I know that Nick and Reggie will follow up with you, but their emails are nick@blitzy.com and reggie@blitzy.com. So feel free to reach out to them directly. And again, we will send the recording and slide deck to all the registrants after the session. And yeah, thanks for joining. I think that that's all I've got. So I'm going to turn that over to my friends, Nick and Reggie. Take it away, guys.
Awesome. Well, thank you so much, Beth, for the brief introduction. Yeah, we'll jump in and do some intros for ourselves. We're super excited to run this today and to get your questions as well. So I'll start out with Reggie, and then we can dive in. So giving a quick intro for my friend Reggie here. He's one of our senior our large enterprise clients. Think engineering teams in the hundreds to thousands on adopting the Blitzy platform, on leveraging our platform to accelerate their software development life cycles. And Reggie has experience as a director in enterprise software development, so working with enterprise engineering teams. He's also a former founder, so he's the perfect blend of innovation and enterprise, and that's I think why we were so excited to bring him on. And now he's been pioneering, really building out our enterprise prompting process and helping teams adopt it. So that's Reggie. I'll pass it back over to you.
Speaking of founder, Nick DiFiore, he is our founding AI solutions consultant here at Blitzy. He was actually employee number one. So he worked on every single team in Blitzy. He's probably prompted every single model, every version of every model. So he is the expert with prompt engineering. I learned a lot from him. He's also strategically advising and guiding our most strategic financial services clients and to an agentic SDLC and the AI native SDLC. And I think that why they paired this up today is because we're both former college football players. So definitely made the connection on that end.
Awesome. Well, with that.
No, so I had a question that I want to pose for you, Nick. So why are AI systems important? And how do we turn an idea into an implemented solution? From a 30,000 foot
view. Yeah, well, great place to start. I think, yeah, great place to start, Reggie. So I think from a 30,000 foot view, like you said, before we even talk about prompting, it's always good to start out talking about, why are we even prompting in the first place, right? Like, why are we using these tools, agentic systems, et cetera? So this is kind of the framework that we talk about, that we think of AI systems in general. So you start out as an engineer, you have an idea, and ultimately that idea, it's valuable, but it's not really worth anything until it's an implemented solution, right? So the goal and why we're using AI development tools and agentic systems, like you can see here, is to take these ideas and turn them into implemented solutions and to accelerate that process, right? So that is really like the framework that we're working off of. Where does prompting and prompt engineering come into play? This is how you instruct your AI system, right? Again, whether it's a development tool or a agentic system like Blitzy, you're going to leverage prompt engineering and writing prompts to effectively communicate your idea to this AI system, and then it's going to go ahead and turn that idea into an implemented solution. So, Reggie, I'll kind of pass it back to you. I know prompt engineering is a term that we hear a lot, right? It gets thrown around. You hear on LinkedIn posts, right, and job openings, there are engineers being hired for a lot of enterprises. But again, it's a very broadly used term. Before we dive into some of the tactics, like what do you think of? What is your definition of prompt engineering from a first principles point of view?
Yeah, and like you and Beth said at the top of the call, prompt engineering is extremely important and in high demand today. Um, what I define as a prompt engineer is the art of stating your intent to build a solution. And I usually like to unpack AI with analogies, and bear with me here. An AI or an agent, when you give it a prompt, it's an actor, right? So it's a brilliant Oscar award-winning actor. It can be a writer, it can be a scientist, it can even be a senior software engineer. But what that actor needs is some direction. So that's why we have directors, right? And the actor without direction, they improvise. And sometimes you get what you want, sometimes you don't get what you want. So I like to think of the prompt engineer as a director, and you're directing a bunch of actors to perform exactly what you want.
Love that, Reggie. Yeah, and forgive me, I'm trying to figure out my screen share for a second. But that's exactly right. And I think when we talk about prompt engineering, give me just a second here. Um, right. So when we talk about prompt engineering, what is the main challenge that we see? And this is something that we see with a lot of our enterprises, right? The challenge is not necessarily the AI system, right? Again, the gem implementing the solution successfully, right? The challenge is successfully and accurately communicating your intent to that system, right? So you have your idea and you want to share that with the system, but what we say here at the top is it's the challenge of translating a 3D idea into a 1D prompt, right? So your goals from an engineering standpoint, the idea that you have is often incredibly complex, and distilling that into a prompt, whether even if it's a really detailed prompt, it is really challenging to do comprehensively. And whatever you communicate to the system, right, it's going to implement. And that's what we've seen, especially as the models have gotten significantly better and more powerful, is that this part of the process of actually implementing your prompt gotten quite good, but where the disconnect really communicate your intent comprehensively and correctly. Um, so, Reggie, I'm curious to hear your thoughts. I know you work with engineering teams, and a lot of the time, what we see when we first start working with teams as they first start on kind of their prompt engineering journey, the question that they have, or they're often running into this issue, right? So, curious to hear, like, when you first start working with a team who's first learning prompt engineering, how do you explain this concept and kind of what are you seeing from them?
Yeah. A lot of times when I'm working with these teams and I'm beginning these engagements, you have two different categories, right? You have someone who prompts the system and they get an output that they don't expect. They're like, wow, AI sucks. And you hear that pretty often. And then you have someone with a more structured and a detailed prompt and really stating their intent and what they want to get out of it. And they get a result, a good result. So same model, bad result, good result. And a lot of times it's exactly that, turning that vision, those ideas, and then putting them on paper and having a definition of, what you want to achieve in that prompt and then the output of the prompt. So that's what a lot of times I'm seeing. And where we fall down as the challenges is creating that structure around prompt engineering. And that's a little bit I'm going to talk about during this discussion. So yeah, so major challenges, so frequent model updates. So every couple months, there's a new version to a new model, whether it's LLM or SLM, a small language model, do a new version. And with those releases, they're releasing uh, more more prompting techniques or different prompting techniques. So how to prompt for this specific version of this model. And as you know, dealing with engineering teams, the most important thing is consistency. We want consistent outputs. We want consistent results, consistent and quality results. So there's some structure that we can put in place. I'm going to talk a little bit about later around that. Prompt drifting, and this is one of my favorites because it's the most common. A lot of times we have a prompt, you get a good result or okay result, and you want to refine it, and then you refine it again, and you refine it again. And once you get to like around 7 or 8 refinements, you start to experience a drift from your original train of thought and your original idea to what the output you're getting now. And that's a major challenge with prompting. Because of that drift, you lose your complete train of thought, your original idea, and then you kind of stray away from what you wanted originally. And the last thing I will touch on this slide is ambiguity. When you introduce ambiguity, referencing that analogy I made earlier with actors and directors, the LLM or the model, the AI system will start to improvise. And a lot of times that introduces contradictions. So once it sees contradictions, it'll either make a decision or say, hey, I'm not comfortable making this decision because it's telling me to do contradictory things, and I'm going to do nothing. So those are the major challenges with prompt engineering, especially starting out in the beginning stages.
Yeah, I think that's great. And Reggie, if I can jump in, I think one of the things that I see most often, just double clicking, is that ambiguity piece, right? So um, I kind of call this the like you should have known that problem, or like everyone knows that. The engineering teams that we work with are obviously a bunch of incredibly talented, incredibly experienced engineers who have been working with the code bases that they work on for years and years at a time, right? So they have this institutional knowledge in their head that is really something that they don't even have to think about, and just when they're writing code on a day-to-day basis, that just ends up in the code automatically. But when you have to communicate this to someone else, for example an AI system, through a prompt, you kind of forget to share that with the system. So it's a lot of these like institutional rules and specifics that your Claude codes or co-pilots or whatever tool it might be, or a system like Blitzy, this is stuff that you've already thought about on a daily basis and just don't kind of think to put in your prompt on a day-by-day basis. That's one of the main challenges I typically will see. I'll jump to the next
Cool.
slide.
Yeah,
Sorry,
and
guys.
how do we overcome those challenges? And the biggest thing with prompting, as models change, there's new releases, new versions. If we want consistent output, as we know, there's 1,000 ways to get to your objective or your core objective, to your success criteria. With consistent output, what we find is having the structure in place. So I always define my core objective. Scope is important, what's in scope, what's out of scope, and then a success criteria. And I really, really want to anchor on those three, let's call them headers, right? So I like to think of a prompt as a weighted document. The top is 80% of what you want to achieve. And then the rest of the prompt is just filling gaps. And in my case, it'd be technical gaps that I want to accomplish. So these three items help me and help clients across the board, all of your peers, to get consistent output with prompting. So Nick, do you have an example where you're just starting out with someone going through the trainings with prompt engineering, and one place where there was structure not in place, where they got an output that may not have been desirable, and then once you put structure in place, what did that output look like?
Yeah, no, it's a great question because that's often what we see, right? It's not, especially with people who have become really accustomed to communicating with the like foundational models, right? Just like a chatbot. So oftentimes when we have people, come in and start using Blitzy, they will almost initially start to prompt Blitzy like they would prompt a chatbot. And that's very informal, very unstructured, right? And what we've found is that by introducing structure to those prompts, not only does it help be tools help, again, your Claude codes, your Blitzes, be able to understand what you want better, but it actually organizes your thinking, and helps you make sure that you are putting in all the relevant information that is going to be required, right? So oftentimes you'll see someone come in and come to us, and they'll write their first prompt, and it'll be relatively unorganized. It'll be kind of informal, like they might be prompting a chatbot, and the output will still be valuable. And that's because, like you alluded to earlier, Reggie, there's some ambiguity there, and the system makes some decisions for you. Ultimately, the output is still correct, but it's some ambiguity in there, and the AI system made some decisions for you. So that's often what we kind of see on the first go around, right? Is ambiguity leading to decisions that maybe you didn't fully agree with. And then we go back and we might run that through again and do another iteration of the prompt as kind of a lesson. And prompting with these pillars in mind and with this specific structure leads to a more obviously structured prompt, but a more comprehensive one that provides all of those like preferences and gives instructions to the system instead of giving kind of ambiguous guidance, which will lead to, again, the system making some decisions for you that might not be fully in line. And Reggie, I'm sure you've experienced this, both in kind of your past life as an engineering director and also with Blitzy. Engineers tend to be quite particular, right, about their solutions and about the code that's written. And so this structure really gives you the opportunity from a scope perspective, especially, to voice a lot of those particular preferences, and helps, again, structure your thinking so that you're providing all those details appropriately.
Yeah, absolutely. Absolutely. And I think a good example, if you click through,
Yep.
a good example of without structure, this prompt right here, design dashboard that's tracking KPIs and revenue generation for each application. This is okay prompt. The result, what you probably get, is a non-functional dashboard, but it designed a pretty dashboard that intends to do everything that you want it to achieve, right? And so with structure, when I add that objective, the scope, and success criteria, I can design a fully functional dashboard that's going to track revenue, KPI, trends for each application, internally, externally for my applications. And the results, the difference in results between without structure and with structure are immense. They're massive. So one area that I wanted to cover here is that I start with these three structures, but we also have the 9 golden rules within Blitzy. So we have 9 rules that we follow with every prompt, and we've seen massive improvements on the output and the results of code generation, or just asking your code base a question. So providing documentation on your code base with that structure.
Right. Yeah. And to double click on this here, looking at the structured prompt, right? You're seeing like very objective success criteria, right? The dashboard should load in less than 2 seconds and 80% test coverage, right? And again, the kind of the difference here is that the output on the less structured one, like you said, Reggie, it's still going to be functional. It's still going to basically do what you want it to. But ultimately, like, as an engineer, you don't want a dashboard. You want a dashboard that does exactly what you want it to do, right? You want a dashboard that loads in less than 2 seconds and has 80% test coverage. Like, all those details are super important. And in the absence of telling the system those details and what you actually want, it isn't necessarily going to provide that. It's not that there's a 0% chance that you're going to get a dashboard that loads in less than 2 seconds and has 80% test coverage. Like, it's still possible that that could be one of the outputs. But in the absence of providing that, like we've done on the left, there's 100 different outcomes that could potentially come with this prompt, and maybe 2 of those are exactly what we're looking for. But by providing kind of this structured description of what we want, we're basically narrowing the system kind of the flexibility to potentially choose a path that we don't want. So, Reggie, I know we've had this discussion before, but like, the process of prompting is almost like, yeah, I'm describing here, of like cutting off potential paths, right? There are, hundreds of different successful paths that could be resulting from this left prompt. And by this prompt on the right that's more specific, we're basically cutting off a bunch of those and trying to narrow our focus down or narrow the system's focus down into what we really want, which is that one specific solution. So I don't know if you have anything to add there, Reggie, but I know we've had many a conversation about that.
Yeah, yeah. And an important piece is describing what you want in natural language. And I have nothing else to add, but
I have a
that's a great
question,
technique that we want
guys.
to
I have a
use.
question coming in.
Go for it.
All right. How different do I need to prompt new releases within the same family?
It's-
Reggie, I think we'll start with you.
It's a good question. And
yeah,
I think that the answer, go ahead, Reggie. You want to start out?
yeah. I think it's exactly. I'm glad we're on this slide. It's this slide. It's creating that structure because, as we know, there's 1,000 ways we can get to our solution, our implemented solution, or our output and our results. Once we provide structure, a clear objective, a clear scope, and a clear success criteria, those agents or the AI system is going to continuously to work to achieve that objective, and it meets the success criteria. And that's how we know we're going to have consistent results because no matter what the model is, no matter what the version is, as long as I can prompt and I'm going to achieve the objective and the success criteria, I'm going to get the same results.
Mm. Yeah,
And I don't know if you have anything to add to that, Nick.
yep, yeah, I'll jump in because I think your answer is absolutely right. Of like with structure, the differences are not significant, right? If you're prompting with structure using this objective and scope and success criteria, that you don't have to change up the prompts too much. The challenge comes when you're prompting without structure, when you're giving more freedom to these new model releases to kind of go off in different directions. And if you are not prompting without structure, or with structure, the answer is that you do need to prompt them quite differently in order to get the same outcomes that you were previously getting on the previous version of the model. And that is frustrating and that's challenging. And I think the biggest frustration is that there's not really a easy way to figure out how you need to change your prompts. It's simply by trial and error, right? So it's just by, we have model one and then model two comes out. And I was prompting model one and things were going really well. I was getting these great outputs. And then we switched to model two. And one day things just aren't working as well as they previously were, right? With the new release. And you have to go through this trial and error process and basically kind of relearn your entire prompting approach every time one of these comes out. And that's truly what we're witnessing is like it is quite different. But that's one of the beauties of this structured prompting style is that by being more prescriptive and more explicit in what we want, every model is going to respond well to that just because that's how AI is built, right? Is to take objective inputs and deliver objective outputs. So by doing that, by introducing structure and objectivity, we kind of cut through those various model releases and the changes because every model release is going to work well with that structure, but every model release is not going to work well without a structured prompt. Awesome. All right.
100% agreed. And Beth, I
Cool.
don't know if you have any more top priority questions top of mind.
Yeah, actually, we have one in the chat here. I'm not a software engineer, just a regular one. We developed an online platform in early 2000s to provide our clients the ability to remotely view, monitor, and manage their refrigeration systems. Our current challenge is to update the software platform to a more modern system that can add some tools, AI tools, as well as improve user experience. Current platform is not as phone friendly as we want. Can Blitzy be used or help with that? And how would our engineers use it? How would we start exploring our options? So challenge is
Yep.
update the software to a platform with a modern system. Sounds like a modernization opportunity here. So I'll turn my camera back off and let you guys take it away.
Nick, you want to take this one or?
Yeah, perfect.
Yeah.
I'll jump in and Reggie, you can come over the top. So,
Yeah.
yeah, modernization use cases are very common, and it's something that Reggie mentioned at the top. Like financial services clients is something that I'm working very closely with, right? Is modernizing these technology stacks. And so taking an existing code base, the first step with Blitzy would be to ingest that code base into our platform, right? And ingestion is where Blitzy is going to develop this understanding of the current state. And then we would go ahead and submit a prompt that basically describes the target state of the application, right? So whatever kind of your dream state is, it sounds like it's a modernized version of the code base. You also mentioned, I think, being more phone friendly. So that would be something that we would probably capture here in the scope as like a detail that we would want of our future state system. And then success criteria as well. So, the framework would be describing that modernized state of the code base within this framework of objective, scope, and success criteria. And oftentimes that's going to involve like a technology stack upgrade, right? So we might specify the new tech stack that we want. And then we can also specify details like you had called out of maybe a more phone friendly version. And that's all going to be captured here in the prompt. And then, I don't want to spoil the end of what happens next of getting the agent action plan and then Blitzy giving you the opportunity to review that in more detail. And then, trigger the code generation and have Blitzy perform a large part of the modernization. But the first step, again, would
Yeah.
be kind of ingesting the code base, developing an understanding of where it's at currently. Reggie, yeah, please jump in.
Yeah, no, real quickly, and then we can move on from the slide. So we deal with large legacy code bases every day, and it's one of the most common use cases within Blitzy. And the really cool part about it is that you don't need an SME or subject matter expertise within these PL1 languages, if it's COBOL or PL SQL or something, Fortran, something that we don't write anymore. We can describe our ideal, our target state, as Nick said, in natural language and perform that modernization effort. So, and I want to tackle like a little bit of that in the next few slides as we wrap
Yeah.
up here.
Yep. Awesome. Cool. And Beth, keep us honest on time. Feel free to give us a nudge if we need it. But
You guys
we
are
should be
doing
wrapping
great.
up.
You're
Good.
doing
We should be
great.
wrapping up in a little bit. So I think we talk about structure, right? That's really like the first pillar of the prompting approach that we use at Blitzy and that we take all of our teams through, right? And we found through trial and error and through a lot of research and reading a lot of the papers and the academics on this topic, structure gets you closer, but it doesn't get you 100% of the way there, right? So this objective, scope, and success criteria, it's really valuable and is going to help the system understand better what you want from a target state, but the gap still remains. And the reason why this gap is here is number one, is it's still one-way communication. I think you all can imagine like working with a human, working with another engineer on your team, if it was just one-way communication and they never had the opportunity to ask you questions before they went off and did a task, that would not work very well. I thankfully haven't been involved in too many of those situations, but I can imagine it would not work very well. And diving deeper into this, like there are always decisions in your prompt that you made without realizing, right? Getting back to this idea of I have so much knowledge in my head as an engineer who's really smart and who has worked on this code base for a while. That I'm not going to always remember to put everything in there every time I do, submit a prompt. And lastly, what the AI, what the system is inferring and what you meant are still going to be two different things. And that's a product of the fact that there is still one-way communication. And again, there are still decisions that you're going to be making. So Reggie, I'm curious if you have any other thoughts on this topic here of the gap
Yeah,
and kind of what you're seeing.
no, I actually have a question. Since we have this gap, how do we change it to two-way communication or bidirectional communication to close this gap?
Right.
There's a question that just came
Yeah,
in.
exactly. And that's, I think, what we're going to get into here is, yep, go ahead, Beth.
I'm sorry. What is the most common prompt engineering mistakes teams make when they first integrate LLMs into production systems? And I think it might be relating to your gap here, so I brought it in here.
Yeah, great question. Reggie, you want to take a first pass at this?
Yeah, one of the most common things I see when engineers come on board and start prompt engineering is they have insane amount of domain expertise, SME expertise within their code base. And then when they go to prompt, the prompt is one sentence, and they want the AI system to be a magic wand and take everything out of their head and create it without telling it. So a lot of times that's what I'm seeing is that with prompt engineering, it's I'm not providing it the relevant context. I'm not providing it the relevant structure, is what we talked about, and I'm not giving it my domain knowledge expertise. And with that, they're going to get a result where the AI system is going to make a lot of decisions for them, and a lot of times those decisions aren't desirable.
Yep. Yeah, and just to jump in with one more point, you mentioned integrating LLMs into production. I think the word production there is super important because just getting code generated is not what we're looking for, right? Like we're looking for code that is validated and that's tested and that actually is going to work within our production environment. And so something that I think teams neglect often through prompting is ensuring that the AI system is going to validate against test cases, right? Or generate test cases and work within the testing infrastructure. Because, like I said, code that has been generated but isn't aligned with your testing, protocols or isn't going to pass those tests is effectively useless, especially in like financial services where precision is so important. So some tactics that like I would recommend for teams is instructing systems to run their test suite or validate or write tests that validate that the functionality works before actually delivering the code. And you can see this with Claude Code, you can see it with Copilot agent mode, and then Blitzy actually does this autonomously, kind of without needing instruction. But that's really important is not just writing code, but writing validated code that works with an existing test suite. So that's another point that I would call out there. Um, Turning now to closing the gap, right? You asked that question, Reggie, of
Yeah.
how do we close this gap? And so what we talk about from a general standpoint is this idea of iterative prompting, right? So refining the plan before you actually code. And I think this line down here that the cheapest bug to fix is the one you catch before it's written, I think is super powerful and a good takeaway for teams. And why iterative prompting is so powerful, because you have the opportunity to refine your plan before the AI system goes off and generates the code. So um, typically, like without iterative prompting, right, you're going to write your prompt, step one, as it's stated here, and it's going to go right into generation. But with iterative prompting, you're really adding in two steps here of reviewing how the system has interpreted your prompt, and then iterating and refining your prompt. And all of this happens before generation. So instead of just writing the prompt and having the system uh, execute on that based on like your first pass at a prompt. You're writing it. The system's going to tell it back to you, hey, here's my understanding. And then you can iterate and refine that prompt. And we'll talk about how this is done with Blitzy here. This is kind of the punchline is that the prompting system that Reggie and myself have pioneered puts iterative prompting into practice, right? So with a lot of existing tools, you don't really have the opportunity to engage in this iterative prompting process. But the Blitzy platform, we've seen the challenge of just doing kind of one shot or one pass prompting where I submit my prompt. And so we built out this prompting system, this prompting process that has iterative prompting baked into it to allow you to perform this refinement before actually going forward with code generation. So what this looks like with Blitzy is step one, writing the prompt of your structured prompt, like we talked about earlier, right? Including an objective, a scope section, and your success criteria. And then instead of just moving right into generation, right, we have these other two steps of review and iterate. So once we submit our prompt, Blitzy is going to generate what's called an agent action plan. So this is Blitzy, like it says here, reflecting its intent back, saying, okay, you've given me this prompt, you've given me these instructions. here's what I understand you want to do, and here's how I'm going to do it. So this is the opportunity for us to basically clarify that the system has accurately understood what we're asking it to do before we go ahead and trigger the generation. So this agent action plan, we can review it, and then we're going to iterate so we can go back and refine our prompt in the case where Blitzy has not kind of fully understood or accurately understood exactly what we want, potentially because we didn't provide some of that context, Reggie, that you were talking about up front. That's so critical. So again, the prompting system that we've developed is really rooted in this idea of iterative prompting and ensuring that the platform understands what you want to do before actually going forward and proceeding with the generation. Reggie, I know that you have walked a lot of teams through this process, so I'd love to hear your thoughts on kind of how you've guided teams
Yeah.
through this and what your experience has been
Yeah.
here.
Yeah, the way I like to think of it, it's really a feedback loop, right? Between stating your intent with the prompt and developing that agent action plan, which I have other names for it as well as implementation plan, or some people call it the playbook, if you will, of what's going to happen. So before code is generated, you know exactly down to the file level, you know what changes are going to be made, and you can iterate on that. And that feedback loop is very, very, very powerful. And I often like to really stress test the system, extract a lot of knowledge through that stating your intent with a prompt in an agent action plan iteration process. And there's a lot of information that you can learn given the infinite context of your code base before you start to generate code. And so it's a very, very powerful step, and it's probably the most used step in the process between that prompt and the agent action plan. And a lot of clients, you know, the most strategic enterprise clients, they find this agent action plan very, very powerful because they go, I wouldn't have thought of it that way. You know, this is a different way of thinking. So this process and creating this feedback loop really closes those gaps that you mentioned. So
Yep. Yeah, it's kind of like a backstop.
yeah,
Like I think we understand it's more than that, but that's one way to think of it. Like prompt engineering is hard, and doing it on a consistent basis, like we've talked about with like model updates with different systems, it's really hard to get right. And so the solution to that, or it's really hard to get right on the first try. So kind of instead of trying to capture all of this and become the world's best prompt engineer, what we have put into our prompting process is just allow yourself to iterate, right? And allow yourself to go through this process a number of times and take feedback instead of, like we said, just spending a bunch of time trying to be the world's best prompt engineer and writing the world's best prompt and relying on yourself to do that over time, every single time. Instead of doing that, just putting this process into play and allowing the system to talk and go back and forth with you before you actually trigger generation. So that's the idea, Reggie. I know you have become the master of this and
yeah.
guiding teams through this. So I don't know
I,
if you have anything else to add.
I
I have a
love the
question from
process.
the chat. I love that. Oh, sorry. Didn't mean to step on you there, Reggie.
No, go for it, Beth.
Okay, cool. We have a question from Richard that came in, and we also have another one from Sohail that is kind of related to Blitzy. So I'll take them one at a time since we're on this Blitzy slide here. In the vein of structured prompts, it sounds as though we would want to predefine our coding standards in a format consumable by the models. Is that part of the single prompt we would build to perform an enhancement, or is it something that we feed separately and it becomes part of Blitzy's base knowledge?
That's a great question. That's a fantastic question. A lot of times we get the question with code generation. It's like, how do I know what Blitzy is going to produce? It's going to produce quality code or code that meets my standards and expectations. And we often ask, you know, back answer a question with a question. What do you define as quality code? You know, what do you define as your standards that meet your expectations? And once they give us the answer, a lot of that is they have that written down somewhere. They documented, you know, what a senior level engineer should produce and those code-based rules, standards, linting strategy, smells. And we highly recommend that we put that in the context window. So within Blitzy, you ingest the code, right? And you can have this infinite code context. We want the code base standards to be ingested as well. So it's part of the knowledge graph. So as I'm generating code, I'm adhering to these rules, these standards specific to my organization. And that's how you know the output you're going to get is going to follow those rules.
Hmm.
A
Yeah.
follow-up question. Oh, sorry, Nick.
Yeah, if I could,
Yep, go
sorry,
ahead.
Beth, could
Yep.
I just,
Yes, please
double
do
click on
add.
that too?
Yeah.
Um, and with respect to like how that's provided to the platform, right? Like that's a separate component or a separate document that you would provide in a separate step, right? So we've found that like instead of stating that in every individual prompt of like, hey, these are our rules, there's a step within the platform called rules, where you basically feed that document in separately, and that becomes constant knowledge that Blitzy would respect with every subsequent prompt that you provide. So it's a separate document that you provide in a separate part of our platform. It becomes a part of your knowledge base. And then every prompt that you submit moving forward, the output would reflect and respect those rules that you specified in the separate knowledge graph input.
I have a feeling that might have answered Sohail's question, which was, I think the cognitive burden of that detailed review can be high, but I think it's necessary. Is there a way Blitzy can make that human step easier? It might be a slightly different lens there, but I'm throwing that into the mix right now. I'll repeat it.
Yeah,
Cognitive
it's
burden.
a valid question. Yep. Reggie, do you sorry, you want to jump in?
So, Beth, can you repeat the question?
Sure. I think the cognitive burden of the detailed review can be high, but I think necessary. Is there a way that Blitzy makes the human step easier?
And I'm assuming we're talking about the PR, the output that we're reviewing.
Let's go with that. I don't have more details on his question.
Yeah, yeah. Yeah, I mean, this is a question that we get all the time. And I will say that with the agentic STLC and code generation, if you're not asking this question, you're not scoping out projects that are big enough. And that's what I tell people all the time. And so, how do I go from reviewing hundreds of lines to maybe 1,000 lines of code in a PR to uh, tens of thousands of lines of code, or maybe 100,000 lines of code? And it's a great question. And a lot of that is through what Nick talked about earlier, is test-driven development. We're going to validate, continuous validate through Blitzy and then ourselves, all the functionality that we're generated through test-driven development. And that doesn't just include unit level, module level tests. We're going to do functional level tests, integration tests. And I like to say, we're going to put your CI within Blitzy. So within the context, so that as we're generating code, we're validating what we want in our pipelines and the steps that we need to push to production as we're generating code. And so that's how we generate quality code. That's how we evaluate PRs that are thousands, tens of thousands, 100,000 lines of code. But that step is extremely important. And Nick, I don't know if there's anything you want to add to come over the top with that.
No, yeah, I think that covers it for the most part. The
Oh, I
only
think
other
that
thing I would
Emery's question is good.
good, go for it, Beth.
Yeah, I have a question in the okay, having used and gained real value from Claude, ChatGPT, GenSpark, Gemini, and other tools, what does Blitzy do better, faster, and what tools does it use? Does Blitzy determine what software would be best for a specific end result or application? Lots of good stuff in there. Because one other question combining with that was, prompting, how does Blitzy keep up with the different models?
Yeah.
So that's just something there. I'll leave it with you.
Yeah, I think these are kind of related questions. So I'll start with the first one, and Reggie, feel free to come over the top too.
Yeah.
Um, how does Blitzy, I guess I think the way I interpreted the question is, does Blitzy make decisions on which softwares to implement that would be best, basically based on the prompt? And I think there's like two different ways that that question could be answered. Like the first is, does Blitzy make decisions about which LLMs to use? The answer is yes. And then the second is, does Blitzy make decisions basically about like what technology stack to implement for my goals that I've specified in the prompt? And the answer to that is also yes, if you want to. So for the first part, Blitzy leverages all of the foundational models of Anthropic, OpenAI, and Google. So those are kind of the three that are underlying our system. And we determine or decide based on the task that is being performed which of those models should be used for each individual task. And that's not just done at a broader like project level when you submit for code generation, but each agent, there are going to be hundreds or thousands of agents responsible for executing your task or your project. And each of those agents has an individual job. And based on the job, we determine which of those models to use, whether it be the Google models, the OpenAI models, or the Anthropic models. Because I'm sure everyone here probably knows and has experienced some of those are better at some tasks than others. And Blitzy essentially makes that decision for you. So that's kind of the question of, does Blitzy decide from a language model perspective which, I guess, software to implement? The second, I guess, way to interpret that question, I think, is around technology stack that's implemented, right? So, for example, if you have goals for your application that are, I guess, more functional and you don't have an opinion per se about what the tech stack should be, Blitzy can make those decisions for you. So if you don't specify, hey, I want this software stack as my target state, Blitzy in the agent action plan will just make that decision for you and tell you that this is the recommended software, this is the recommended tech stack that I suggest. And again, through this iterative prompting process, you have the opportunity to review that and to adjust it. So it can make that decision. If you have preferences on that, if you have an opinion, you just specify it in the prompt and Blitzy will respect that. But if you don't have a preference, Blitzy can make that and make that suggestion based on your higher level functional objectives. So hopefully that answers it. Reggie, you have anything to
Yeah,
add?
and I'm gonna take a slightly different approach and
Hmm.
talk about the key differentiator and the key value drivers, within Blitzy. We are a pre-ID tool, and with that, we
Hmm.
have infinite code context, so you can ingest 10 million, 100 million lines of code, and Blitzy will understand deep relational mappings down to the file and module level of your code base, and then inference time compute. We are the most inference time compute platform on the planet, and I do want to emphasize that. And with that infinite context window and then the inference time compute, we're really able to impact large scale projects. So batch processing at scale, and we
Hmm.
can affect that quarterly or yearly roadmap, within a project, right? So we can ingest a lot of code, and we can really impact, that bottom line by executing that project in 5x velocity. So.
We're coming up against time,
Hmm.
Nick and Reggie. Are there any final thoughts before we close this out? There are some questions we didn't get to, but for everyone who did ask a question in the Q&A or in the chat, we promise to get back to you with a detailed response. Any final closing thoughts as we wrap it up?
Yeah, Reggie, do you want to close things out? I know I've got this slide here that I think is a good summary.
Yeah, so definitely want to recap. So prompt engineering, it's in high demand. We're all becoming prompt engineers, at work, in our personal lives. We're using the underlying models, LLMs, SLMs. Where we want to do what we want to do is state our intent, and it's an art through a build prompt or prompt engineering, and get a desirable result. And what we talked about is within our organization, the 9 golden rules, and providing that prompt structure so we get consistent results, no matter what the model is, no matter what the version is. We get consistent outputs and desirable results. And I really want to anchor on those 9 golden rules of providing our objective, our scope, and success criteria. And Nick, is there anything you want to come over the top with the prompt engineering? Love to hear.
No, yeah, I think that's those golden rules that are on our dev docs, I think are super valuable for folks that we've worked with. And yeah, I mean, just to summarize, I think like the main challenge that we see is not comprehensively or accurately communicating your intent, right? The systems and the models have gotten really good at implementing whatever we tell them to, but the disconnect is between the human and the system itself. And so with Blitzy and the framework that we've kind of presented here, um, providing a structured prompt and then an iterative prompting process through the Blitzy prompting system, it really solves for or helps solve for most of that gap between the human and the AI system, which leads to better solutions or more accurate and implementable solutions at the end of the day. So that's I think how we'd wrap it up. Beth, we'll kind of pass it back over to you for any, I guess, closing questions or closing thoughts too.
Great. Yeah, thank you. So again, questions that were put in the chat in the Q&A, we will absolutely get back to you. We'll also be wrapping this up. We'll be sending you the recording. Again, apologies for those network blips that we had off of the top there. Hopefully you got a lot out of this. Thank you, Nick and Reggie. Great job. And thank you all for spending time. So one of the things that we do want to let you know about is we have another awesome webinar coming up. Blitzy 4.0 has a Figma to production integration. So save the date for March 30th. And I will just call out that this, I know other tools claim, this Figma to production capability, but nothing is really going to be like what you're going to see on the 30th, where we actually go right to production from the Figma files, because we can, Lovable and Claude Code are great tools, but they can only get you part of the way there. They can't get you all the way to leverage your component libraries, and they require a lot of cleanup, manual cleanup. So Blitzy reads your Figma file, node trees, respects your component library, and delivers the responsive front end with 100% design fidelity. So you're going to want to check that out. We'll be posting about that soon. Again, thank you everybody for being here. We appreciate you, and we will be following up with you for our next webinar and with the materials from this webinar. Thanks, guys.